I'm going to discuss principles of object-oriented programming in our object-oriented programming in Java course. This is lesson number 4. Okay, so let's look at this sentence. There are 4 main principles in object-oriented programming. In object-oriented programming, okay, there are 4 main principles. One thing is encapsulation. Okay, then the second one, inheritance. Third one, polymorphism. And fourth one is abstraction. And so first look at what do we understand by encapsulation. Okay, so this one, read this sentence. Okay, encapsulation is the ability of a class to be a container for related attributes and methods. So now I have taught you about the graphical notation of a class, and it has 3 parts, no? In this way it has 3 parts. This one here we include the name of the class, and here we include the attributes, and here we include methods. Now ability of a class to be a container for related attributes and methods. Okay, so example, the class student encapsulates the attributes and methods related to a student. Now we were working on a class called student in our previous lessons, and now student, if you consider student class, its attributes are related to student. Okay, its methods are related to students. Okay, student. In that way, if you consider one particular class, there we encapsulate. Understood? We put related attributes and methods to a capsule. Okay, that's the meaning encapsulation. Okay, so now another, when we discuss about encapsulation, then we meet another concept, that one is called data hiding. Okay, data hiding. So in our previous lesson, in our lesson number 3, about we discussed access modifiers. In this lesson, now you know, using access modifiers we can control the access to attributes and methods. Okay, using access modifiers. Therefore now we can perform data hiding. For an example, if you make attributes private, they are accessible only within the class they have been defined. Okay, there are through getters and setters we can access from outside, but direct access is allowed only within the class they have been defined. Okay, therefore we can achieve data hiding. using this concept of encapsulation. Now let's look at the second one, that is called inheritance. Okay, now read this sentence. Okay, inheritance is the process by which one class acquires all the attributes and methods of another class. Okay, so if you have one particular class, there is another class. Okay, so if we acquire all the attributes and methods of this class to this, okay, that process is called inheritance. Okay, inheritance, normal English word. Okay, so we have the same meaning. Inheritance is the process by which one class acquires all. This one is important. All the attributes and all the methods. Okay, so now let's rewind. Can you remember the two classes? Then you again, it's better you look at lesson number 1. Okay, our very first lesson. There I was talking about two classes, student and teacher. Okay, so now I have shown you here. Now if you look at attributes, name attribute is common to both of the classes and age attribute is common to both of the classes. And also if you look at display method, it is also common to both of the classes. Okay, then here it says, note that the attributes name and age are common. Also the method display is common. Okay, now what we have to do? Let's create a class called person with common attributes and methods. This process is called generalization. Then if you have two classes like this, student and teacher, okay, these are the two classes, and I'm not going to write attributes and methods. You can assume they are there. Okay, so now here you can create another class called person, and here you include the common attributes to both of these classes, and here you include common methods to both of the classes. And this process we call it generalization. The process of generalization. Okay, then now we can inherit from this class as follows. This process is called specialization, and in this way, now once we have done this generalization, then you have a class. Okay, you have a class where you have included common attributes and methods. Okay, so this is a standard symbol. Okay, so here we should use not this symbol. Okay, you have to use something like this. Okay, for inheritance. Understood? That is a small mistake here. you have to, your array symbol, array head should be like this. And now we then in this direction we do generalization. That means you extract common methods and common attributes and common methods and create a class with them. That process is called generalization. Once we have done that, then you can do specialization. That means you do it something like this. Okay, then you will understand this when we discuss practical examples. Okay, these concepts are easier when we combine them with a programming language. Okay, that is why I am using Java to teach these concepts. Okay, and now let's read this. The class person is called the parent of both classes, student and teacher. Okay, for these two classes we call this class parent class of this class is a parent of this class. This class is a parent of this class. Okay, and now in other words, classes student and teacher are the children of the class person, and if you consider this class, these two classes are children. Okay, so now let's implement the class person. Okay, let's implement this one. This person.java file should also be stored inside the folder codes. Okay, so in earlier situations we were working inside the folder called codes, and we had stored their student .java and likewise. Okay, so anyway, let's see. Let's see our code. Now let's start Notepad, and here class person private char name. Okay, so now you know usually we use private access modifier for attributes. Private, therefore we have private int age. Now now if you look at this, okay, there are two attributes which are common to these two classes, and therefore if we create our own constructor, we have to use the name exactly same as the class name, and there are no return types. And now char name and int age, okay, these are the parameters. And now here this dot name, so these things are now clear to you. So age, okay, so this is our constructor. Now now let's save this. Let's save this one. Okay, I'm going to save this inside a folder I have already created, double OP. Okay, so here I'm going to save it, and the name you have to use the class name dot java extension. And now here you have to use then let's use setters and getters for each of these attributes. Public void set name char name this dot name that is the setter for our name attribute. Okay, then again public char get name return name. Okay, here we can either use this dot name or just name. Okay, no ambiguity here like this. Okay, therefore we can simply use name alone. Okay, and then for the name attribute, now this is the setter and the getter. Now for the age attribute, we need setter and getter. Public void set age int age this dot age then this one public int get age. Okay, now here we have to return age. Okay, for the age attribute, this is the setter and this is the getter. Okay, now there are only two attributes, therefore public void display system.out.println. Here we put name or either you can put this dot name. Okay, since there is no any ambiguity, you just use it as name. Then system.out.println, here you put age. Okay, now we have completed our person class. Okay, now you can see two attributes. These are the common attributes for student and teacher class, and display method, this is common to student and teacher classes. Okay, but body of the method is different. Okay, so let's discuss it later. Okay, then we have to create another Java file. Class student. Okay, then here we use extends person. That means we inherits from person class. Okay, we inherits from person class. That means now let's see our person class. Okay, in our person class we had name attribute and age attribute. Okay, this is our person class, and also we had method display. Okay, this is our person class. Now we are going to create our student class. And we are going to inherit from it from person class. Okay, so in order to do inheritance, we can use extends keyword. That means if you use something like this, class student extends, okay, class student extends, then here person. Now in this way we are going to implement our student class now. That means all the attributes and methods, all the attributes, that is the meaning of inheritance now. All the attributes and methods of the person class will be available for our student class. That is the meaning. Okay, so that is why here in the student class I had not included name and age, and in teacher class also I had not included name and age. Furthermore, here I had not included display method. Here I had not included display method. The reason is now these those two attributes and the method are there. Therefore, when we use the inheritance in these classes, they will be available. Okay, we do not have to include them in the class. Okay, so now let's look at the implementation. Here we do not have to include name and age. Okay, only other attributes you have to mention here: marks, maths. Okay, then private, double, marks, English, private, double, average, private, static, double, AVG. Now I hope you can remember our previous lessons. Okay, so first save this one. Inside the same folder we had person.java file. We are going to save this one as well, and here you have to use the class name is student.java. And now if you can remember what in our previous lessons, then this is the average. Average is computed by these two values, average of these two values, and this one has a separate copy for each student object, and we have to compute the whole average of all the average values that is stored in this attribute. Therefore, we only need the single copy for AVG attribute. That is why we have made it a class attribute by using a static keyword. Okay, then we have to create the constructor. Before that, I will complete this one. This is our graphical notation now. Okay, this is our graphical notation. Marks, maths, marks maths, marks English, okay, average AVG. My graphical notation is not complete, okay. We have not specified axis modifiers and data types of the attributes, parameter list, return types of the methods, and those things are missing, okay. I just wanted to explain this concept, okay. So this is not a complete class diagram. And now AVG, okay, these are the attributes, and anyway this one is a class attribute, therefore we can underline. Then for the methods, now we do not have to include display method, it will be inherited, therefore other methods we include okay. This is our student class, okay. And now let's see. Here we have to include the constructor public student, name is exactly same as the class name, and here we have to pass name should be, we have to pass, okay. So there should be a name for a student, no. Then char name, int age, double marks maths, double marks English. In this way we can include the parameter list. And now here, now name and age attributes are not here, okay, they are inherited, okay. We have not written them here, but they are available, okay. So because we inherits from person class, and these two attributes will be inherited to our student class, okay, but we cannot access them in this way. This dot name, in this way we can't do, okay. We cannot use this keyword, okay, since they are inherited attributes. You have to use super keyword, super, okay, super here, super, then you pass name and age. The meaning of super. Now in earlier situations I have told you, if you use this keyword and something like this, we are referring the constructor of the same class, okay. And if you use super keyword, then like this we are referring the constructor of the parent class. And that means constructor of person class we refer using the super keyword, okay. And the other thing is, for a given Java class, okay, there can exist at most one superclass. Okay, at most one superclass for a given Java class. This is, in this way it does not occur. This is wrong. Okay, at most one parent class. Superclass means a parent class. That is a synonym for parent class. There exists at most one parent class or a superclass. Okay, parent class, superclass, they are equal, synonyms. Okay, there can exist at most one parent class for a given class in Java. Okay, but for a given class it may have any number of children. Okay, there is no restriction for that one. Okay, restriction is only for parent classes. And now it is like this. Okay, so we can invoke, in this way we can invoke this constructor. Okay, this one, and then in this way we assign values to the attributes name and age. They are available here, but they are invisible. We can't see them, but they are available. In order to assign values to those attributes, we have to use the constructor of the parent class. Okay, now I hope the thing is clear to you. Now rest of the attributes values we can, this dot marks maths okay, this dot marks English. In this way we can do. Okay, now this one we do not assign a value within the system. Using the system we have to compute that value. In our previous lessons I have explained this, and this one also we have the system should compute it. Okay, we are not going to assign a value for these two attributes. Okay, so then let's see. Here we include getters and setters only to these two, not only to these attributes. Okay, these attributes, other getters and setters will be inherited. Okay, they will be inherited. Now here in this diagram I have not included setters and getters. Okay, actually I must include them. Getters and setters I must actually include, but so let's keep it like this, otherwise the diagram will become complex. Okay, therefore getters and setters, they are also methods, no? Then according to inheritance concept, all the all the attributes and all the methods will be inherited to the child. Okay, therefore when we do not have to include setters and getters for name and age attributes. They are available here, but they are invisible. Okay. Now here I am going to include, yes, public double get marks maths return public for the marks maths attribute, the getter and a setter. Then for marks English attribute, we have to put a setter and getter. Okay. Okay, this is the getter for marks English attribute. This is the setter for marks English attribute. Okay, now let's include getter for the average attribute. Okay, so then For the average attribute, we only put a getter because we are not going to set a value. No, within the system, the value of the average attribute should be computed. In the same way, for AVG also, we just include only a getter, and here this should be a class method because our attribute is a class method. Therefore, here this one is a class attribute, therefore our method also should be a class method. Okay, and now we include public void cal average our cal average method. Okay, then we have already discussed these methods, therefore I just write the codes. Cal avg student int variable, then avg, initially avg value is 0.0. We put a for loop to access each average value of each object. We use a for loop, and here okay, then this one average, and we get the sum of average attribute of each object. After that, final value we can get by dividing the sum by n. Okay, so then we can include display method. Now in person class also we had display method. Okay, so in person class also we have display method. Now here we are going to include the display method. Okay, so by ourselves. If we do not include the display method, what happens? If you do not include the display method, then this method will be available here. Okay, so if we include the method by ourselves, the inherited method will be overridden. This one is called method overriding. Method overriding. Okay, so in inheritance, now student class will acquire all the attributes and all the methods. Okay, so now here I'm going to include a display method by ourselves. Therefore, this inherited display method will go away. Okay, instead we include our own display method. Okay, this process is called method overriding in Java. And now here now if we want to display name and age attributes, they are not available inside the student class. Okay, they are available, but we have not typed it. Okay, they are invisible and they are available. So in order to access, in order to display them, we can simply use super keyword. And now you know, from the super keyword we refers the parent class. Okay, super keyword is used to refer the parent class. This keyword is used to refer the same class. And now here we invoke display method. That means we are using display method available in our person class. Okay, their name and age attributes will be displayed. And now then we use system.out.println maths marks maths here English marks English. Okay, then system.out.println okay, this is our display method. Now you have to properly understand the use of super keyword. Okay, so we referred the parent class. Okay, we referred the parent class, and here also using the super keyword we referred the parent class. That means the construct of the parent class. Okay, and now this is our student.java file. Now it's the time to implement teacher.java file. And now here what we are going to do, now you know our teacher class in teacher class let's go back to the diagram. Okay, ours rate salary. Those are the three attributes, three additional attributes. So we inherit from person class, therefore name and age attributes will be inherited to the teacher class, and they will be available but they are invisible. We cannot see them but they are available. Okay, so then display method will be inherited, and cal salary method, here you can include it, additional method you can include it here. Okay, then and now this kind of a diagram, okay, this is a diagram, it's clear to you. This kind of a diagram is called class diagram. Okay, class diagram. Okay, if you want to model an information system, if you want to develop an information system, okay, before you develop it, you have to design it. Okay, before you develop it, you have to design. If you are going to build the house, then if it is a very small house, even without the design you can do that. But if it is a big house or a hotel, then you have to draw a diagram, draw a plan, then you can build. Okay. In the same way, if your information system is a complicated one, then in that situation first you have to design the structure of your information system. In order to do that, there are many diagrams. Okay, class diagram is one of the most important diagrams. Okay, this is a very simple example for a class diagram. Okay, now now I'm going to start another notepad. There what we do, we have class, teacher, we use extends keyword, and person. Person is our parent class, therefore all the attributes and methods of the person class will be available to the teacher class in invisible form. Okay, so now only the additional attributes we include here: private double hours, private double rate, private double salary. Then let's include a constructor of our own. Teacher, in the parameter list, name of the teacher, then age of the teacher, then rate, payment rate of the teacher, we include it like this. Now name and age attributes, they are available inside teacher class but in invisible form, therefore we have to access them using the constructor of the parent class. So we pass name and age as arguments. Then now here this dot rate. Okay, so this is the additional. Now in the constructor we do not assign a value for hours. Okay, because at the initial creation of a teacher object, we know only depending on the qualifications of the teacher, then those who recruit, they assign a value for the rate. Okay, they assign a value for the rate. And now in this way we can include the constructor of your own. Okay, now let's include cal salary. Salary is computed by multiplying. Yes, before that let's save this inside the same folder, and here you have to put teacher, that is the name of our class .java extension, And now salary is computed by multiplying the rate. Rate means how much is paid for 1 hour. If you multiply it from the number of hours, then we can compute the salary of the teacher. Now for the salary attribute, then we include just a getter, no? So we are not going to set it within the system. The value of the salary is computed. Therefore, including only a getter is enough. Here return salary. Now again public void display. Okay, now again in this class also we are going to override the inherited display method from the person class. We are going to override. Okay, so super dot display. Okay, using the super keyword we invoke the display method in our super class. Okay, then you can display, using this one you can display name, values of name and age attributes, and here we include the rest. Out.println hours, system.out.print salary. Okay, now we have yes, again let's see. Now we use the extends keyword. That means we have inherited from person class, and then all the attributes and methods available in the person class are inherited to our teacher class. Now name and age attributes are available here, but they are invisible. Okay, and we include only the additional attributes, and in the constructor now in order to assign values to this age and name and age attributes, we can use the constructor of the person class. Person class is the parent class of our teacher class. Therefore, in order to access that, we can use super keyword. And here also, now due to the inheritance, we have got an inherited display method here, but we are going to include a display method, the name similar to the display. We are going to include signature similar to the display in our parent class. Therefore, the existing inherited one will be overridden by this method. Okay, so now in order to access the display method in our parent class, here also we can use super keyword. Okay, that is the summary of our teacher.java file. Okay, now it's the time to include the driver class, where we have included the main method. Okay, so again I will include notepad, and now class test public static void main. Now I hope you can understand. Public keyword, that is an access modifier. That means this method can be accessed from anywhere. The static keyword, that means this method is a class method. This is the return type, and this is our main method. So string args means in the parameter list we have an array of strings. Okay, here. Now we create person P. Okay, person P. Before that, let's save it. We have to save it inside the same folder we had other files, test.java. Now to P, I will explain this one. Okay, let's type it first. Now student. Now we are going to invoke the constructor in the student class. This one. Okay, so we have to pass name, age, marks maths and marks English. Okay, so here okay, now let's again talk about how these objects are created on computer memory. Now you have some understanding from our previous lessons. Okay, so now you know we have a stack and heap. Stack and heap is there. Then person P, that is a reference variable. This one is a reference variable, therefore it is created on the stack. Okay, and here we, using the new keyword, we create an object of type student. There now in this object we have name is there, age is there, because they are inherited to the student class from person class. And here we put L here. Okay, and age is 34. Age is 34. Marks maths 56. Marks English. Marks English. Then 75. Okay, 75. This is our student object. Okay, so now the other thing is reference variable is of type person. The type of this one is person. Type of object is okay, then now we have seen the reference variable. The type of the reference variable is of type person. Okay, person, but our object type is student. If we create a reference variable like this, okay, reference variable like this, definitely in this reference variable we can store the memory location of this object. Okay, but here in Java we can do something like this. This is our parent class, no? So if you create a reference variable from our parent class, Okay, in that situation we can store memory location of a child object in that reference variable. Okay, now here person is the parent of student class. Now when we create an object from our student class, its memory location can be stored in a parent reference variable of the parent class. Therefore in P we can store this. Okay, in P we can store this. Okay, now let's run and see. Run and see. Okay, now let's start the command prompt. Okay, then we have to be inside OP folder and java c test.java. We compile our compile test.java file. No errors have occurred. Now here you could see the number of files multiplied. Okay, that is because once we compiled and run the driver class, then relevant object files were created. Okay, and now let's run this java test. Now what you can see here, this is our object. Okay, so now this is our object. So we invoked in this line, we invoked p.display. p.display. p.display, and now display method relevant to this object. This object is an instance of our student class. Therefore now p.display means display method relevant to this object. That means let's go to the student class, this one. Okay, that is why we had two values, L34, 56, 75, this one and this one. Okay, here and some head titles are missing, no? Therefore we can just go to our person class, and here we can include name, plus let's again now you can see it with titles. Okay, now again let's put a new line. Let's put a new line. System.out.println p new now what happens after execution of this line of code? Okay, definitely an object of type teacher will be created. An object of type teacher here. Then let's open our teacher Java file, and here and it inherits from our person class. Therefore we have name, age, hours, rate, salary. Hours, rate, salary. These are the attributes for the name attribute. We will have M. For the age attribute, we will have 42. For hours, we do not assign anything, and its data type is double. Therefore, it will get the default value 0.0. Okay. Okay, now rate is 300. Okay, this is the constructor we invoke. No, name, age, rate is 300. Rate means the amount paid for the teacher per 1 hour. Okay, and salary we have not yet computed, therefore it is 0.0. And now we are going to assign it to the reference variable p. That means here p is pointing to this object. In other words, p is storing the memory location of this object. That is possible because in earlier time I told you. Now if you create teacher t reference variable, definitely in this reference variable we can store the memory location of this object. But in Java, if we create a reference variable from a parent class of this class, that means person p, then in p we can store memory location of objects of its children. Okay, children classes. Okay, objects of its children classes, their memory locations can also be stored in this p reference variable. Okay, that's what we did here. Okay, now then let's use the display method. P dot display. Now P dot display means display method relevant to this object. Display method relevant to this object. Okay, so that means if you look at the teacher class, this display method. Okay, then let's see, let's compile and run. Now you can see here the values I had put, M42 0.0. Okay, here also titles are missing, therefore we can add hours, then this one rate, and here salary. Okay, then now again compile and run. Now you can see those values, M42 0.0, 300 0.0. Okay, then that is then again let's read this sentence. The keyword extends is used for inheritance. All the attributes and methods of the parent class are inherited to the child classes. Now here this is a diagram now. In order to convert this diagram to the Java code, so here for this arrow, in order to convert this arrow, we used extends keyword and okay, then when we use extends keyword, all the attributes and methods of this class, okay, will be available for this class. All the attributes and methods of this class will be available for this class. Okay, that is what we mean by inheritance. Understood? Okay, then the term all is important. Okay, then another thing, parent class is a synonym for superclass. Here person is a parent for a student class. The person is a parent for teacher class. And also, in other words, we can say person is a superclass. Person is the superclass in Java. Okay, because in Java there I have told you there can exist at most one parent class. Therefore, for the student class, person is the superclass. Okay, for the teacher class, person is a superclass. Okay, then again, child class is a synonym for subclass. Okay, so now person class has two subclasses, student and teacher. In other words, person class has two children, student and teacher. Now you meet the term subclass. Subclass. Then we have met this one. Okay, when we were talking about access modifiers, okay, then when I discussed protected access modifier, I told you that you cannot understand that at that moment just because this access modifier needs understanding about subclass concept. Okay, so now you will get that understanding in this lesson. And now it says Method overriding is a feature that allows a subclass to provide a specific implementation of a method that is already provided by the superclass. Okay, that's what we did here. Then we had person. In person class we had a method called display, and then in the student class also we included the method with the same signature. Okay, and in the teacher class also we included a method with the same signature. In these two situations we have overridden the inherited method of the person class. Now you know, since it is available here, it will be inherited to this one and this one. Now if you include a method where signature is similar to display, then that inherited method is overridden. Okay, understood? That's overridden. Okay, that happens. Okay, so that is called method overriding. That is a concept in Java. Okay, note that we have overridden the inherited method display in both classes student and teacher. If we want to refer the original method, we have to use the keyword super. Now that's what we did. Here in student class, if we want to refer, now display, if you want to refer the method, display method in the parent class, here we used super dot. We have done that inside the student class as well. We have used super dot. Okay, look at the keyword super found inside the constructors of the classes student and teacher. It is used to refer the constructor of the super class person, and you have seen this. Okay, you have seen this in student class, you have seen here, and also in the teacher class you have seen it here. In both places we referred the constructor of the parent class, constructor of the super class. Okay, so if we try to replace this line with the following two lines, what would happen? Okay, what would happen? Then we are going to use let's say in one particular class, instead of writing this one, instead of using the let's go to the student class. Instead of this, let's see what happens if we try to access super dot name in this way, super dot age, and then compile and run. Let's compile and run and see what happens. Then it says has private access in person. Okay, so that means if you look at person class, here these two attributes are private. They are available only inside the class they have been defined for the dot operator. Okay, therefore using the dot operator we cannot do this. This is wrong. Okay, that's what I want to explain. Okay, now instead of now what happens? Now let's move to this protected access modifier. Okay, so when we were discussing access modifiers, I have told you if you use protected access modifier, one thing is if this is a package, and in access modifiers lesson I told you just think package as a folder for the time being at this level. Okay, so if you have an attribute or a method that has used protected access modifier, then that attribute or method is accessible within the classes in the same package. Okay, but outside the package, okay, the classes cannot access this attribute or method, but if it is a subclass, then it is accessible. Understood? Within the package or for a subclasses, protected attributes or methods are accessible. Okay, that's so now that part I have discussed in access modifiers section is clear to you. Okay, then instead of private access modifier, let's put in person, let's put here protected access modifier. Then here in the student class, let's keep it as it is. Then let's compile and run. Okay, then test.java file, yes, our student. Then what is the error we get? Constructor person in class person cannot be applied to given types. One error. Okay, so here okay, once you have done that, also you can see an error. Okay, so here if you read this error carefully, actual and formal argument lists differ in length, that is the reason. Therefore you have to understand in this way also it's not possible. Okay, therefore we have to use the constructor of the superclass. Okay, so for the time, yes, now you know, in earlier time yes, then the use of protected keyword. Okay, so protected access modifier, let's discuss this in detail. This needs a detailed discussion. Let's discuss it in exercises related to this lesson. Okay, for the time being this knowledge is enough. And now Now let's see. Let's again here. Let's change it as in our earlier situation. Okay, so it's like this, and now let's look at the class test.java. To a superclass reference, it's possible to assign memory location of a child class object. Okay, so now here I have explained this. Here I have done that. This is a reference. P is a reference variable of our parent class, and this is the child. So memory location of the child object can be stored in superclass parent class reference. Okay, so that's what I wanted to say here. And this line, a class in Java can have at most one superclass but can have several subclasses. If we consider one particular class in Java, it can have at most one superclass, 0 or 1 superclasses for a given Java class. But there can have for a given class in Java, there can have any number of subclasses. Okay, there can have any number of subclasses. That means 0 or more subclasses for a given class in Java. Okay, now let's go to the next one. Polymorphism. Polymorphism is the ability of an object to take on many forms. Okay, so the most common use of polymorphism occurs when a superclass reference is used to refer child class object. So if you look at this, here we use P to invoke display method. If p.display means we invoke the display method related to this object. Okay, in here the same text, but we use to invoke the display method related to this object. Okay, that is an example for polymorphism. And then let's look at about abstraction. Abstraction is the act of representing essential features without providing background details or explanations. Okay, there are two ways to achieve abstraction: abstract classes and interfaces. First, let's look at abstract classes. And one important thing is we cannot create objects from an abstract class. Okay, if we made a particular class abstract, okay, that can be done by using abstract keyword. I will tell you it soon. Okay, so once we have made a particular class abstract, then we cannot create objects from that class. Okay, so now we can add, in this way we can add abstract keyword in front of a class. Okay, so then our person class, if we use abstract abstract class person, and again let's run compile and see. Okay, without any errors it has run, and then again try to do something like this in our test.java file. Let's try to the p reference variable, let's try to create an object from person class. Okay, we invoke this constructor. For the name, let's put k45, and now let's compile and run. It gives us an error, person is abstract, cannot be instantiated, because now if we made a particular class abstract, then compiler will not allow us to create objects from that class, but we can inherit from that class. From its children we can create objects. Okay, so this is useful if the programmer wants to restrict creation of objects from a particular class. Okay, we can use the abstract keyword, and then definitely in order to get a use from that particular class, we have to inherit from it. Okay, so that's one thing. Okay, then this line, let's remove this line because it gives us an error. Now let's move. Yes, abstract classes can be used as the superclasses of inheritance. They may or may not contain abstract methods. Then if you consider one particular abstract class, inside that abstract class we can include abstract methods. Okay, then what do we mean by abstract methods? An abstract method is declared without a body. It is something like this. Without a body we include a method. Okay, so the superclass which are not, just within brackets it says which are not abstract, the superclasses of the abstract class must implement all the subclasses of the abstract class must implement all the abstract methods available in that abstract class. Okay, so now one thing is if you have a given class, we can make it abstract class. Okay, and suppose you do not have any abstract methods inside that particular class. Okay, in that way also okay, but if we included at least one abstract method inside a particular class, then definitely you must make the class abstract, otherwise Java compiler will give you an error. Okay, then the other thing is, let's say if you have an abstract method, once you inherit from this particular class, and in this child class must implement this abstract method. That means to the body of this method we have to include something in the child class. Okay, if we fail to do so, then we have to make this class also abstract. Okay, that means this is the theory. If a class contains at least one abstract method, then that class must be made abstract. Okay, that is why this happens. Now the second method is to use interfaces. An interface is a named collection of method signatures. We cannot include attributes in an interface. It is included, if included, then they are implicitly static and final. Okay, so now okay, now this is an example for an interface. Okay, so we can include method signatures. Method signatures, I hope you know. Okay, method name, then parameter list, then we put a semicolon, and these are examples for method signatures. Okay, here semicolon must be there. Okay, so that error you have to correct. And the keyword implements is used to realize. Now in inheritance we call inherits, and if from a class, if we do this, we call this class inherits from this one. Okay, but if it is an interface, then we call it, we use a dotted arrow like this, and we call it realize. And here we use extends keyword. Okay, you have seen that. And here we use implements, the keyword implements. Here we use implements. Okay, so and the other thing is a class can realize any number of interfaces for a given class. Then I have told you there can exist at most one superclass, but this can realize any number of interfaces. Okay, any number of interfaces can be realized by a given class. Therefore, the interfaces can be used to facilitate multiple inheritance in Java. Multiple inheritance means something like this. So inheriting from several classes, more than one class. In Java, this is not available. In Java, multiple inheritance is not available. There are programming languages which support multiple inheritance, but in Java, we do not have multiple inheritance. Therefore, to facilitate that concept, we can use interfaces. Like this, we can use interfaces. Okay, so this is an example. Class webcard implements iWebcard. Okay, this is an interface. So this is the keyword you should use. Okay, that's how we did that. And so now we have discussed and we have finished discussing 4 fundamentals of object oriented programming. Okay, so I have used Java programming language to demonstrate those four concepts, but using many programming languages, uh, you can use these four concepts: encapsulation. Okay, so capsule, it's like a capsule. Student, if you consider a student class, it contains attributes and methods relevant to the student. Okay, so if you consider teacher class, it contains attributes and methods relevant to the teacher, relevant to teacher. Okay, so if you consider a class called course, in this situation, in this institute, in this situation, this class contains attributes, course name, course code, likewise attributes related to the course class, and methods related to the course class. Okay, in that way it is like a capsule. Capsules, pills you have seen, we encapsulate something inside. Okay, so capsules, so you have to understand it like that. Then second concept, it is inheritance. Okay, so all the attributes and methods of the parent class will be available to the child class. Okay, that is called inheritance. And we discussed these two concepts. Then we discussed polymorphism and using P, person P. Okay, then to invoke display method in this object as an object from this class as well as an object from this class. Okay, that is polymorphism. Then that is just an example for polymorphism. You have to learn it further. Abstraction. Abstraction, there is a definition for abstraction. Okay, so let's move to that part. Abstraction is the act of representing essential features without providing background details or explanations. There are two ways to achieve abstraction. One thing is through abstract classes, and the other way is through interfaces. And here and now you might feel why we need abstraction. Okay, that feeling is there, but you have to understand, if you develop a very complicated system, a complicated information system, then in that case organization of the structure of your information system is also essential. Otherwise you will not be able to work with it. Therefore that is why we have concepts like this. And now in our object oriented programming course, okay, now I'll talk about our object oriented programming course. Actually, object-oriented programming in Java, actually I used Java programming language for this course. Okay, for this course. And we had 4 lessons: lesson 1, lesson 2, lesson 3, lesson 4. Okay, so then in the first lesson, then we discussed about classes and objects. Okay, then after that we discussed about methods, and then in lesson 3 we discussed about access modifiers, and this is our last lesson. We discussed about principles of object oriented programming. Okay, so this is our last lesson. Now for each lesson we had exercises. Okay, in that way I have managed this course, and for this lesson also we have an exercise. Okay, then after completion of lesson 4 you have to try the exercises related to lesson 4. In order to try that, you need the knowledge of lesson 1, lesson 2, lesson 3 and lesson 4. Okay, and that is the end of this object oriented programming course. Thank you for watching the video.